Welcome back. In this session, let us explore the basic input-output function. Dear friends, for any program, there are mainly three actions: input, process, output. In C language, any action, not only input, process, outputs are, any action is performed by a function. So every C program consists of one or more functions, and one of those functions must be main function. We all know that C program execution begins at main. Dear friends, C language by default does not provide any function. But don't worry, it provides standard library. See, the C standard library contains header files. In the header file, we find the standard library functions which provide the basic function. So together with the compiler, we get this standard library, and the library contains the header files which contains the library functions to provide the basic function. See, normally these header files contain function prototype, macro definitions, type definitions, etc. The most important header files are stdio.h, which contain the standard input-output library function. String.h header file contain the library functions which provide string manipulation. stdlib.h header file contain the library functions which provide memory management. And math.h contains the header files which provide mathematical calculation. Similarly, there are different header files which contains the library functions providing the basic function. Whenever you want to perform an action, you need a function. You check for the function in one of the libraries. If the function is available in any of the library or the header file, you include the header file in your source code and write the program. Suppose if the function is not available in any of the library, then you have to create your own function. Therefore, we can classify the functions in C language into two types. One is library functions which are available in C standard library, or the functions created by user for his own purpose. We call them as user-defined function. In this session, we are interested in library functions, that too standard input-output library function. As I mentioned already, C language by default does not provide any facility, not even input-output capability. If you want to provide this input-output operations, you need to include stdio.h header file. In stdio.h header file, we find the header file or the standard input-output library function. The most important standard input-output library functions are: for input, we have getChar, getS, scanf. For output, we have putChar, putS, and so in this session, we explore these. The first one is getChar. See, getChar reads a single character from standard input device and returns the ASCII value, my dear friend. For example, you see, we define a character variable x and you call this getChar function. So it will prompt for a input of a single character. When you enter the input, the ASCII value is assigned to x. So if you print it, %d will give you the ASCII value, %c will give you the character. So that character is assigned to x. So getChar will assign characters in this manner, my dear friend. The next one is putChar. So putChar takes a single character as input and it prints that particular value or the character. It prints the character, not the ASCII value. And after printing, this fellow returns ASCII value also. That is very interesting. Let us try to see with a simple program. Let us consider this simple program. Here we define a character variable ch. GetChar scan a single character and that is assigned to ch. Char will print the character, and this printf statement is very interesting. Here the argument putChar ch will print the character, then it will return the ASCII value of the character, and this %d will print the ASCII value. Let us run this code and verify the. Here I input the value a and see the output. Here friends, this putChar will print a, then second putChar again prints a, then there is a tab, so there is a tab followed by %d, which is ASCII value of character a, which is 65 is conversion specification. The conversion specification tells the printf function how to format a value when you are going to print it. So for conversion specification, it should start with a percentile sign followed by a specifier. We call it as conversion specifier, yeah, format modifier. So percentile C is having meaning single character, that is character will be printed. With respect to printf, percentile D will print decimal integer value, percentile O will print octal integer, percentile X will print hexadecimal integer, percentile U will print unsigned integer value. My dear friends, with respect to printf, the effect of percentile D and percentile I is one and the same. But when you consider scanf, the percentile I is having special meaning. See, normally, if you define a variable and using scanf, you want to assign the value to this particular variable, that is percentile D conversion specification if I use it. If you input the value 512, yeah, 0512, yeah, 0x512, the percentile D will ignore these prefixes. It will always store the value 512, my dear friend. But if you use the conversion specification percentile I with respect to scanf, depending on the input, if you input 512, the 512 will be stored. If you input 0512, that octal number value will be stored. If you input 0x512, the hexadecimal value will be stored. That is the difference between percentile D and percentile I with respect to scanf. So it is having special meaning with respect to scanf. Remember that. Now for fractional form, the conversion specification is percentile F. For exponential form, the conversion specification is percentile E. The percentile G is the special one. If the number is a regular number, fractional form will be printed. If it is a very small number or very large number, the percentile G will print scientific or exponential. Remember this. Let us consider this simple program. Here we define a variable a and we assign the value 512 to it. Now we are trying to print the value with percentile D, percentile I, percentile O and percentile X. So we should get a decimal format, here octal format and here hexadecimal. Because percentile I or percentile D will print decimal format only. Let us run this code and verify. So here you see 512 printed in both the cases with percentile D or percentile I, but with percentile O, octal format is printed and with percentile X, hexadecimal format is. Now let us try to scan the value of A and print. Scanf using percentile D. And remember, you have to use ampersand A here. Now let us run the code and verify the output. So this time I want to give the output 5 and 2. So you got the same output. Now let us try giving the input as 0, 5 and 2. We are trying to expect the octal format, but still it will give you 5 and 2, 5 and 2, 1000 and 2. Or let us try 0, 5 and 2. But here this O, the ASCII values are considered, so you are getting some unexpected result. They are not, decimal equivalent of octal of 5 and 2. So don't mess up with this. See, the percentile D will not identify the prefixes, or it will understand the way the O is printed. Am I clear? Now, let us try with percentile I and see the same output, my dear. Let us save the program and run. Here, first let us give the input 5 and 2. You will get exact input. Now, let us run this and try to give the input as 0, 5 and 2. Now, it will consider this as octal number. And you see, the decimal equivalent of 0, 5 and 2, octal number 5 and 2 is 330. That is print. So, it is storing that octal number. When you print percentile D, the decimal value you are going to get. When you print percentile O, octal format you are going. Not only this, try to run this with the input 0x 5 and 2. And you are going to get the corresponding value. The octal format is 5 and 2. And you see here 1298, 1298. That is equivalent 5 and 2 hexadecimal number equivalent decimal. You can just verify that, sir. For example, 5 and 2 you want to convert into decimal format. 16 square into 5 plus into 1 plus 1 into 2. So that you can verify, that is equivalent to 1298, my dear. You can verify. Now let us verify the conversion specifications for float. So here using scanf, I'm going to scan the value of this float variable. And I'm trying to print it using percentile F, percentile E, that is floating form, scientific form or exponential form. As I mentioned, this percentile G, depending on the number, either it will give you the fractional form or exponential. So let us try to run this code. So here I am going to give the input like 12.34, a regular number, and see the output. Here percentile F will obviously give you the fractional format, and percentile E will give you the scientific format, and you see percentile G is given 12.34, which is fractional format. Now let us try to give some big value or small value and see what happens. Small value, and let us run. Now here you see percentile F given the fractional format, percentile E given the scientific format, and G also given the scientific format. So whenever you input the small values or big values, the percentile G, depending on the value, if it is a very regular number, fractional format it will give you, but if it is a very large or very small number, it will give you the exponential. Now you can experiment with big number also. Let us run with some big number. 12 power 5. Okay, let us see. And you see here it is given fractional form. These two fellows are given in exponent. Actually 12e 5 means what, sir? 12 into 10 power 5. Big number, so obviously the scientific or exponential form is printed. The conversion specifications can also be used together with the modifier. That is, we can use modifier H together with the specifiers D, I, O, U, X to specify that it is a short integer. For example, if I use percentile HD, it represents short integer. Similarly, modifier L will tell you the long. So whenever you write percentile LD, it represents long integer. Suppose if you write percentile LO, it represents long integer in octal form. So L stands for long. So L can be associated with all these specifiers, my dear. Again, L also can be associated with floating specifier. L with F or L with E or L with G stands for double. That is fractional format, exponential format of double. LF means double, fractional format. Percentile LE means double in exponential format. And again, percentile LG, as I mentioned, LG, it is depending on the number, either fractional or exponential. If I use capital L, it stands for long double. So we can also use this modifiers together with the regular conversion specifier to get a particular meaning, my dear.